All right, so now I'll go to another slide. We have maybe about 10 or so slides over here. Whoop, I'm sorry, there it went back. What you see here highlighted in green with these little green check boxes is information on videos that we have made. So I'll show you those, a little bit about those videos here in a couple of minutes. All right. And so some of our next steps, we are working with Shusheng Wu, who I think some of you maybe have heard a presentation from. And so we are making collabs, making, I don't know really how to explain them because it's a little confusing for me, but basically we're converting the code into Python. So all of the code of the book, we're going to have a second place that has all of the code written in Python. So it's possible to come here. We have a lot of visitors to the site, which I'll show you in a couple minutes. So we also have these author videos. So for about maybe 30 or about 30 videos, I think, where the authors walk through the videos from the beginning to the end. And those are, that's a YouTube channel that I created, and really that everybody else created by explaining their chapters. But we have these videos, and I think they're pretty great. The idea of the videos is for people to be able to view it in their own language, right? To view the captions in their own language, and then I think also within a few years, probably to hear the audio of what the person is saying automatically translated into their own language, so that if English isn't the first language for a person working with Earth Engine, they'll still be able to understand what the ideas are inside the book. That's my goal. So we have multiple entry points that you see listed here. Okay, you see multiple entry points for the book. And there are people, it's designed also, especially really, the beginning is for absolute beginners who don't know any programming at all. I'm going to teach a workshop on Earth Engine in May here in Montreal, and I'll start with this chapter, F1.0. That's for people who don't know anything about programming or Earth Engine or remote sensing. They are just absolutely beginning. I'll show you that for a few minutes. And then we also have ones for people after that, people who've taken Earth Engine 101 but are working alone. Maybe it's not for their job, but they are just interested in learning Earth Engine more. And so we have chapters on F2, classifications and regressions and accuracy, F3 for reducers, and then looking at the shapes of clusters of pixels with image morphology techniques. Then I mentioned the time series interpretation algorithms there in F4. And then for very experienced users, we also do have sophisticated things in there. So for me, for example, I wanted to learn how to do a join on a collection, to join two collections to each other. I knew I had seen it in the book, so I went and looked it up. And then I was able to use it for my own, to use our book for my own research. So it's pretty great. All right. And so I'll mention again that we have this YouTube channel, and then I'll show just a couple more slides, and then I'll go and show you the book. All right. So this is a very wide range geographically. People are using the book all around the world. It's been really, really exciting to see that people are using this book. It's just a wonderful feeling to create something and have other people care about it. So I'm really happy that there are so many people who have used this book over time. And so I think it is pretty great. All right. Also, we just discovered recently, I went to the page for the book at Springer, and it said that almost 1 million people have accessed the book, which I'm not sure I believe it exactly, but I think that it seems to be true. relative to the number of visitors for other kinds of books at Springer. For sure, it's something that people are using. So I'm really very, very proud of all the work that people have done on this. And so if we go and look at the chapter reviews, I think one of the things that helped a lot with the quality is that we have a lot of reviews of these chapters, and the reviews really made the chapters better and better and better. So this is probably a little bit old. I think we have a few more reviews than that, but this was especially for preparing the book. So for the very first chapter, there are 30, more than 30 reviews, and we keep track of other items about the users as well, the interest of the users. And so we ask, how long did you spend on this? So for someone who is an absolute beginner and starting with F1.0, typically people spend about 1 hour working on that first tutorial. That was by design, that the first one is easy. Here it is with the intellectual difficulty. We want that to be easy. Then we want it to get a little bit harder and seen as a little bit harder as we go, but still take about the same amount of time. And so we spent a lot of time moving things around in the draft versions of the book. And then we also want it to be worthwhile for people to spend their time. So I'm really happy to see that people say that it was worth spending the time on this tutorial. So if you are ever interested, you can stay in touch either by contacting me. Nicholas can send my address around. I guess my email address is on some of these slides here too. And we could encourage you also to go and do any reviews of the chapters if you want to. You can then view what those are. Videos that people are making will show up. And then the website for the book, and that's what I'll click on now. And finally get to the website for this book. All right, so maybe I'll move, sort of zoom back a little bit, hopefully not make it too small. But here at the top, actually maybe I'll zoom in for a moment so that you can see at the top what we have. So we have the book itself. We can move here. The foreword is written by the manager, the boss of everybody for Google Earth Engine, Rebecca Moore, pretty amazing. And then each of those chapters or sections that we'll go to. Here I'll click on the videos page. If we go to the videos page, that shows you what it was that you saw. Sort of a shrunken down version, but we can, if you want, if you are doing this chapter on exploring image collections, you can click here, and then that will play that for you. All right, and I see a little typographical error here on F4.1, and I'm going to fix it because there should be an S here, exploring image collections with an S, and so next time you come, that'll be fixed. It's a great thing about having a book that is live and a website that's live, is we can make these changes as we go. So let's go and look at the first chapter in the book, and to do that, I'll move it back to its normal size, which is a little bit smaller, and then come down and go to show you section F1. So we have the this entire document. Whoop, I need to share the tab every time I change between different tabs. There we go. And so this whole book basically, to me, is a set of Google documents. So for anyone who can see Google Documents, they can see this book. And if we then move, we can either scroll down or click anywhere here on the left, and that will bring us to JavaScript and the Earth Engine API. Now, the author who we got for this is this really wonderful person named Ujjwal Gandhi. And what I will do for a moment is tell you about his project that he does that's separate from this book, but it's the reason I think that he's pretty well known. So what I will do is I'll click on share this tab instead, and go to his site, which is Spatial Thoughts. So you may have heard of this site, but I really think it's an amazing thing, and I want people to know about it. And so, in case you don't know about it, this is what it is. So this is by that same teacher. He used to work at Google, and now he runs this this teaching company. And for a pretty small amount of money, about $100, sometimes $150, he teaches courses and directs people through these courses. And so he has one that goes all the way from the beginning to end of Google Earth Engine. He has a course, Google Earth Engine for Water Resources Management. Here, I'll click on that and we'll see what that looks like. I haven't taken this one. I don't really know about it, but it is about 27 hours long. And basically he teaches first Google Earth Engine fundamentals, code editor, JavaScript programming. So that's a lot like the first chapter of our book. And then how to make mosaics and composites, doing thresholding by looking for, using this algorithm called Otsu's method to look through the data in order to find what a good threshold is to separate water from land. And then some stuff with precipitation time series analysis. I forget what the data layer is called that he's going to use for that. Chirps, I think it is. And then doing land use land cover mapping. And so basically on each of the days, it's probably 2 or 3 hours a day for 7 days. So it's maybe 4 hours for a few of the days. And then there are a few assignments. And then you're able to get a certification describing that you have completed it. And so that's just one of the courses that he teaches. I took the Introduction to QGIS class. I usually work with ArcGIS. I'm a professor teaching with ArcGIS, but I want to learn QGIS because a lot of people use QGIS. And so I took this course, and that's when I started to recommend this Spatial Thoughts, because it was very, very helpful for me. It was just 12 hours, maybe it was 4 days, 2 or 3 hours per day. And we learned a lot about QGIS. I didn't know anything about it before, and then it became understood afterwards. And one pretty amazing thing is that he offers lifetime technical support. So you can just write back to, I think it's ujval@spatialthoughts.com, and ask a GIS question. He's just a wonderful person, and I'm really proud to know him. All right, so that is, hold on, we wanted to go here. And so all that is behind the first chapter. Now, I'm not going to go through all 55 chapters in that level of detail. But what I want to show you is here, getting started in the code editor. We refer to a repository, and I'll show you that in just a moment. The code editor, describing that. And we begin with the classic beginning of all programming knowledge, where we say hello world, and then go, yeah?
You have not switched to the other
Oh, I
side.
didn't switch. Yes, thank you. Sorry.
Okay.
That's fine. Yeah, interrupt me again if I do that. Sorry about that. All right, so we'll go back here. I'll mention, here's this repository. Here's printing hello world. Here's in text, we're describing how it is that you begin Earth Engine for, your first 5 minutes with Earth Engine. What do you need to learn how to do? How do you save a script first time you do it? Creating a home folder with a new repository. And then some of the basics of JavaScript. So he teaches about that for a little while. And then at the end here, if I go to synthesis, I think there's a small assignment. suggesting how to write out some information. Again, this one is not really about Earth Engine very deeply. It's just a pure introduction to the idea of programming, using functions, and writing things out onto the screen. Then in F1.1, we move to exploring images themselves inside Earth Engine. This chapter was written by a professor at a small teaching college in the United States, and he teaches Earth Engine every semester. And he teaches remote sensing, with that he teaches, remote sensing through Earth Engine. And so we found him, and he has a lot of experience teaching. So he helped, he wrote this and with the idea to help people to understand how Earth Engine itself allows us to view images. So here you can see he took this picture, and then there's A and B and C, and then, or A and B at least. And so then he explains what those chapters or what those parts of the interface are, explaining that Landsat has more than three bands, but that we can view those 3 bands on top of each other. Then we can combine them. And so for those of you who are not beginners, who already know Earth Engine or already know remote sensing, you maybe look at this and say, okay, yeah, those are the basic ideas, right? That's what you probably already know how to do. But for someone who's just a beginner, we wanted them to be able to start at the beginning of the book and then get all the way caught up in a way so that everyone becomes at the same level, the same level of understanding. Then in chapter F1.2, survey of raster datasets, it allows you to then move through the different kinds of data sets that there are. So here we're drawing an entire image collection. Then we do a print, and we see that there are 1 million images inside the Landsat 8 collection at the time. Now, when we wrote the book, I realized we needed to note that this number is constantly growing, because if you run this code, we will see that this number is bigger than 1,276,000. And maybe we'll try that after in a minute or two. So we explain filter by location and the different things that you can do, how to get the first image onto the screen. First image happens to be cloudy there in Minnesota. And so here you can see a little bit. My view of the document shows me little notes that we have inside the document. Here you can see some of our checks that we did in preparing the book. So here it says, save your script for your own future use as outlined in chapter F1.0. So we had multiple people make sure that this reference is correct. So there in chapter 37, that might refer back to chapter F1.4. So we had people checking to make sure that all of these references were accurate. And so those, in my view of the documents, are spread throughout the document. But I figure I'll show it to you to give you a feeling for what it took to make everything kind of fit together and work, to integrate with each other so that the document made sense and continued to make sense. Google helped us by hiring 2 full-time editors, and those editors helped with doing things like 500 needs to have a space before the letter for meters, and 250 needs to have a space before the meters. Across 1,200 pages, there are a lot of different styles for writing. And so they read every word of the book, and they edited the entire book from the beginning to the end, and helped it to have a similar feeling, even though it was different individuals wrote the book. So we wanted it to sound like the voice of the person writing, but to have a unified feeling to the book. I think that worked pretty well. Then I'll just finish this little part off by showing the remote sensing vocabulary. And that vocabulary, what we want people to learn are the phrases spatial resolution, spectral resolution. Here, if I go down here a little bit more, I'm going to try to not jump over it, but it walks through TM imagery, MODIS imagery, MSI, which is Sentinel-2, and what it looks like. And then if we zoom back and see all of them all at once for MODIS, Landsat 5, and Sentinel-2. And then there is a thing, I think maybe limited to the United States, I don't remember, NAIP, which is some aerial photographs. So we put that in there. And then we look what they are when we had those. And so here is that idea for looking the beginnings of, inside the book to show people the first chart that they will see. And we want them to see the first data types that they will see, or the first data sets that they will see. We then go down to some other types of data sets. Let's see if I can get down here. Oh no, that's in the other one. So there's an assignment that we give for people to work on. And then those are all the different types of pieces of the remote sensing vocabulary that you can see. I guess I noticed there's one other of these quality checks here, which is this student who's now a graduate student. She went and looked up all of the references in the entire book, one by one, hundreds and hundreds and hundreds of references, and created them in Mendeley and then brought them back in here so that they all look the same, so that all of the text was the same, and that it looked like one unified thing. So at the end of every single chapter, she wrote references created, and then the rule was I would then write thank you, and then we would know that she had seen it and that I had seen the work that she had done. Now, sometimes I click on these to close them and sometimes I don't, but there are hundreds and hundreds and hundreds of all of these things that are still, they're still sitting there. And so maybe someday if I'm bored, I'll go and clean them all up. But for you, what this means, I think, is that you have something that produces, or that has produced, a high quality introduction to the skills that are needed to use Earth Engine at its most basic level. So, I went very quickly through these. JavaScript and the Earth Engine API, that's the basic one. Let's see if I can make this maybe a little bit bigger for you to be able to see those words. JavaScript and the Earth Engine API. F1.1, exploring images. That was the different colors of the bands, that kind of stuff. And that included this image. I went too quickly to notice this image, but this is one of the pieces that is shown here for exploring images. Then F1.2, the survey of raster data sets, and then F1.3, the remote sensing vocabulary. So that's the most basic beginner part of the book. And the idea here is that people can begin with absolutely no knowledge at all, and then can move all the way from no knowledge of any programming at all the way through learning just enough JavaScript, and then being able to come all the way forward to the remote sensing vocabulary and understand that. Then, for people who need those things, those chapters are there. But if you are a person who doesn't need those things and you just want to learn about masks, which are very confusing to me always, if I want to learn or remember about masks, I can skip this part and jump to this part. There's no requirement inside the text that says, please take your result from F1.3 and use it. If I saw that, then maybe I would quit doing the chapter, because it's, I don't want to have to do every chapter in order to do this chapter. So the chapters build on each other, but they're also meant to be independently contained for each other. So that's our hope, and I think it's gone pretty well. Then when we get down toward interpreting image series, one of the work that I have that I'll show you in a little while is here inside of Data Fusion merging classification streams. And so that is the work that I'll show you for my own. And so that is really the idea of what we have for the book. We offer it to everyone. Anyone who wants can go and check out this book. You can see it just here at eefabook.org. You can also, similarly, you can find it by Googling for cloud-based remote sensing. And then that brings you, most likely, will link you to this site. And you can click on that site and come here whenever you want. So that's the first part of what I will tell you. Just to return back to the overall picture of what I'll talk about. That's this first part for the Earth Engine book. So I think what I'll do now is take any questions for a few minutes, and then we'll just take a break for 1 minute and then come back. All right, so if anyone has any questions, go ahead and ask them. Okay, that's fine. That's all good. No questions. So let's 9:30. Okay, let's start in, and I'll tell you about my own research. Okay. So yeah, so the book is open access, absolutely. So we can go.
So,
Yeah, go ahead, please.
so in terms, I was asking in terms of now the contribution. Uh, are people allowed to now contribute to the book? Now, not on the side of now reviews. Yeah.
Yeah, so far we are not adding on to the book so far. Part of what
Okay. Okay.
and the reason is part of what I want you to see when I was talking about all of these little checks and pointing from one place to another, and then the work that she did for the last little parts with the references. We had the writing of the book is one thing, but making it all fit together was half of the job. It was an enormous job to make all the pieces work and to have all of the code also work. And so for right now, it isn't open adding to it. But if any of you have any things that you're interested in, that you maybe have tutorials that you have written, we're making a list, and when that list becomes big, maybe we'll make a second edition of the book. So that's the idea so far.
Oh, thank you. Thank you.
Okay. So let's
Yeah.
see.
Okay. Thank you.
All right. So one other thing that I want to show is I'm not sure exactly how to share Safari, which is the other platform. I don't know whether I can do that or not. Maybe, how do we want to do that? I want to show you the link. Tell you what, let's do this. I'm going to stop presenting. You can stand up and walk around for 1 minute, and then when you come back, I'll have the other thing shared, and you'll be able to see it. All right. So you can click stop presenting. I'm not going to leave, but I'll just click stop presenting and then figure out how to have it be connected to the other thing. So it'll take just 1 minute. Okay, let's see. All right, so you should see now the Earth Engine interface. Um, and what I want to show you is the repository for the book. So here, if I go back to the text, you'll notice here, for example, the practicum no, I want to do the exploring images. So you see this code, first image equals blah, 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 print it out onto the screen. Then let's go to, oh, I know. Here, we'll scroll down to that image, that picture that I showed you of the night lights. It's down here. And I mentioned this picture. Okay, so you saw this picture with the Nile Delta there around Cairo. And you might see this picture and you think, I want to make that picture. Oh, I didn't change the tab. Darn. Okay, here we go. So I've been zooming around in the book. Sorry again. Here we are, this tab for nighttime light changes in the Middle East. So you think, oh, F1.1.13. So that's the chapter F1.1, figure 13, nighttime light changes in the Middle East. And if you remember, I showed this for a moment and said, this is the picture for one of these chapters, and we use it to represent what's inside of F1, the introductory section. And you think, well, I'd like to make this. How do I do it? So what you could do is to go back and click again and again and again, and you have the ability here with the Google document to click 3 times on any code and then copy it. Okay, so here if I click 3 times and copy it. One of the things that we did was I had a student work all summer to go through all of the code and make sure, well, set it up so that you could click 3 times on it and paste it. He wrote an entire piece of code to make these colors be exactly the same colors of Earth Engine's colors, so that when you moved from here to Earth Engine, it would feel the same. So what I want to show here, section 7, here's this piece. And here it says code checkpoint F11C. The book's repository contains a script that shows what your code should look like at this point. So what is the code repository? Here, if I go up to the top of that one, F1.1, again, this is the professor at that small college. Here it says, if you've not done so, you can add this book's repository by clicking on this link. So if you click on this link and you get it there, what you get is this thing, and it brings you this repository. Okay, and this repository here says projects.gee.edu/book, part A, applications, part F, for fundamentals, and that's what we want, F. That was F 1.1 C, I think. So I haven't prepared this, I just am trusting that the book is going to point to this. So here's F1.1C, and this should be all of the code that we saw for all of those parts. All right, and so I will run that code, and I'm hoping very much that it does what I'm promising. So there's that image that you see. And then my hope is if we come over here to Egypt and we zoom in, that we should see the same thing. All right, so if you see anything at all in the book that is an Earth Engine product, you can make it by coming over here and pushing one button. That's the goal of the entire book. So the idea is you can then take this code if you want and do save as, copy it for your own purposes, and then adjust it for either for teaching or for learning how it works. So you might be curious about F182013, the nighttime lights data set. I don't know the nighttime lights data set very well, but I could use this code in order to figure out how better, what it is. And so that is the idea of the code checkpoints. All right, and so I'll come over here, move back just a little bit, and show you that we have a lot of code checkpoints. So here's, F3, then you go into here, there are 3 checkpoints for that. And I mentioned that we're converting all of these code checkpoints, we're making them so that you could also run them in Python. I don't know Python very well at all, but I hired some high school students who know Python, and they are converting this stuff into Python. So here's F51C, whatever that is. You can go here, you push the button, it will run, and it will run all the way to the end. This figure will look exactly like the other figure that you see in the book. And so that is what we are talking about when we say the code checkpoints. And so the idea here, the biggest picture idea, and then I'll stop talking about the book, but you can see I'm really excited about the book. I love the book, is that it allows a few different things to happen. Here, I'm going to switch to this tab. It allows any person to begin learning Earth Engine, even if they don't have experience. Even if they're not like good at programming, it allows you to triple click on code, copy it into the editor, and push the button, and you get the picture. So that little by little, you can learn. Any person, I think, can learn what is programming, how do I use this, what are the pieces that I need to learn how to do in order to be able to learn how to do it. So I guess one very last thing, if I click on advanced image processing, I clicked on F3. If I go to F3 and I say, what do I need to do? I want to learn about neighborhoods and filters and passing them over on top of it, defining kernels in Earth Engine. What do I need to do? It says you need to understand all of F1 and you should understand F2 in order to do this one. It doesn't say you need to do 3.1. It doesn't say you need to do 3.0. It says you just need to do F1 and F2 in order to do this. Then we have a little description and we do. So I'll come back and return, and then I will absolutely finish talking about the book. But we offer it to everyone as the question of, is it an open book? It's open for everyone to read and use. Earth Engine is open for anyone who starts, who gets an account. Of course, we all know that, but other people may not know that. And so it allows you to get all the way caught up to be able to make every one of these images that you see here. These images just represent the ideas that are there. But I think they're pretty neat, and hopefully it is useful for everyone. All right, so I'll stop there for the book, finally. All right, so now I'll come all the way back. If there are any questions, please feel free to jump in. But just so that I know that you're listening, maybe you could click on some reaction, just like a smiley face or something, so that I can see that there really are people out there, just to make sure, if you could do that. Okay, that's great. Wonderful, thank you. I'm not trying to get you to clap. I just really mean, like, I want to see that people are hearing it. So thanks a lot. Great. And I couldn't tell if you mean to raise a hand. Feel free to raise a hand, or I think maybe you're just saying the thumbs up. But if there are any questions, just go ahead and jump in and start talking if you want to. You can feel free. Okay, so thank you for clicking on those things. I appreciate it.
Prof, I think there are some people here with some questions.
Real questions. Okay, sure. Nicholas, do you want to manage? You call on the people, okay?
Yes. Yes, Pius, please, you can just open up your mic and speak. Okay. So I think Pius is not able, but also Han, you had raised your hand. You can open your mic if you want, right? Okay, so let's continue, Prof. So probably they will get their questions later in the time.
Yeah, no problem at all. All right. So what I will do now is move back to here, which is part one. That's the end of part one. And now we'll talk about part two with BULC-D Earth Engine program for change detection. So this is my own research. Let's see. How many slides do I want to show? I have a lot of slides. I think I'm going to not show them all, but I will talk through them quickly, but I won't spend a lot of time on them. The idea is I want to give you a chance to run the program that I describe here, if you want to. All right. So this is some of the work that I do for my research. And the idea is it uses Bayesian statistics. Whoop, I forgot to share the tab. Here we go. All right, I'll go back one. This is Introduction to BULC-D. That's my research. So I'll just say informally, what is Bayesian statistics? And the idea is if these are loaded dice. So if you know what that means, they used to have dice even back in the Roman times, and sometimes people would drill out the middle of the dice and put in some lead so that it would show up on one side and be a number that was more that was not random, and then make bets. So if we were doing a dice roll and you see a 2, you think, okay, well, what's the probability that it's an unfair dice? I have no evidence that it's unfair, really. But if I see another 2 as the next roll, maybe I become suspicious and think, that is not normal for me to get 2 2s in a row. I don't think that that's right. Or it's unlikely, but not perfect. But then if I get a third 2, actually I would write 100%. I think I would be 100% sure that it was not a fair die. And if I got another 2 after that, I would for sure say that I would expect that it was not a fair situation. And that would continue as many as I got. But what if I got a 2 and a 2, and if they were more careful with where they put the lead, maybe I got a 6, and then I got a 2, and then I got a 2. My probability, my mental thinking about is it fair or not fair would change through time and move from maybe 1% to 20%, down to 15 or 2%, then back up to 80%, maybe then 90%, then maybe 100%. And it doesn't have to be that I get a 2 all the time in order for me to believe at the end, almost 100% sure that it is unfair, that the dice are loaded. So this is an idea of this feeling of Bayesian statistics. And so I think of it as, what do we learn by having evidence from a lot of different sources? And with this program that I wrote for my research, we try to do that. So what I do is you take in an image, you do a rough classification of that image, then we do we create a transition table, do some math, very simple math, and then come up with a 3-layer image that represents the probability of each of those layers. Now this is tracking a fire, which I'll show you here. Here's what the images from that fire look like over time. You can see there are a lot of clouds. Here's their smoke. There's a gap. We create these rough classifications. With our eyes and our brains, we can see that the classifications are not perfect. What bulk allows us to do is to use these classifications without trying to make every one of them perfect in order to produce a probability of change through time that turns out to be very accurate. Now you see all this dark, you see the red, that's the fire. You see the dark stuff. The dark stuff actually is lakes, and so those are, we have a lot of lakes in Quebec. We have like 100,000 lakes in the province here in Quebec. So we end up with a history of estimates for every pixel. If I click on one pixel, I see what is my idea of whether it's burned or forest or water. And we published it here in this great journal. And that has turned out really well. So here, I'll just go back, sorry. If I go back here we're also able to use the same code for taking a rough existing classification. Here you see it's very rough on the right, and then we feed it new images, new classifications, and then we get a sharper and more correct image classification when we are finished. So this goes through a cycle of 12 images or 10 or 12 images and creates a better classification with unsupervised events. We are, and this is published by one of my master's students from a while ago, 2018. I guess that's a long time ago now. And so you can see here, it sharpens this image over here, which is called globe cover, and that was made at 250 meters, I think, with MODIS data. And then we sharpen it, and it is more accurate. Here, this is in Brazil. We can do the same thing, sharpening the classification and going back in time, and that's another paper that student did, and that turned out great. So this is the most, I think, the biggest paper that we have that represents really all of the work that, you know, the idea here represents it the best. And so here on the left, we take in images from all different kinds. So Landsat 1, 2, 3, and 4, Landsat 5, CBERS, which is, it's in Brazil, and this is the China-Brazil satellite, Landsat 8, Sentinel-2. They're all different resolutions, and they show this area changing through time all the way back from 1972 up to the year, I don't know, 2016. And so this is an unusual algorithm because it can take in data from all different, can bring in data from all different sensors, a lot of different sensors and different resolutions, and it can have some clouds in it, there can be haze, there can be some errors, and it brings it all in and creates this fantastic classification over time. All right, so this is what we've got. We also have the ability, we're bringing in radar that we can have in here, and the idea is to have a near real-time detection of change. And this is the work from one of my students, and she speaks Spanish, so this slide is in Spanish, and the idea is to have a near real-time deforestation system. We also can do bulk with Dynamic World. Some of you may have heard of Dynamic World, which is image classification for every Sentinel image is produced by Google. So they have these rough classifications up here on top, and they show how the area maybe changes or maybe not. Usually it's mostly noise. And what bulk is designed to do is to ignore the noise. And so that is what bulk can benefit in this area. And so that is a use of bulk with Dynamic World. We can also reclassify Dynamic World images just to be a few different categories. And here they are here. and then it can produce a final classification. We can get some sense of our confidence in the categories, and here's the classification plus the confidence being drawn here. If you want to learn about this, this is F 4.8 in the book, and so it's that processing multiple data streams part of the book. All right. And so we have created an interface for it that an undergraduate student in my lab wrote, created this interface in Earth Engine to allow you to bring in data from Dynamic World and then produce these interesting pieces from it. Now, the new work that I will show and turn over to you in just a few minutes is called BULC-D. And the idea is the D stands for deviation from what we expect. So the concept is like this. If we have a lot of images and we use maybe the NDVI, or here I use the NBR, the NDVI returns some numbers. The numbers often are very similar to each other, and typically they're the same year after year. So here's what I expect to see in a new year. And you can see I do get that all the way up to about day 200. Then I get evidence that says that number is different, more evidence that that number is even more different, then even more evidence over time. So the idea here, what is similar to what I was talking about with the dice. Here, you can imagine it's like we're rolling dice and we get the numbers 1, 2, 3, 4, 5, and 6, all the, a bunch of random numbers. And then over here, we get 2, 2, 2, 2. And so it is when it's 2, 2, 2, 2, then we begin to think that something is unusual in this area. And so we'll do that. We would then say, I think something is unusual. I get a 2, and then I get some other numbers, but I'm not getting random numbers anymore. They're not fitting what I expect to see. And so I use Bayesian statistics for that. So this one is, this is like a technical detail of how it works. I take all the values and turn them into like bins of expectation around a normal curve. And so you can see them. And so it's like this. We get a bunch of 5s and 6s. Those are normal numbers. And then we start getting very low numbers. Those are in bins 1 and 2. If we see a lot of bins 1 and 2, then we believe that something has changed in a pixel. And I'll show you this for your own area. All right. So BULC-D is very good at forest change. I'm not sure if it's as good in areas that are not forested, but I want to ask you to try to find that out. So my student Flavie did this for change over all of Canada for the year 2019. I'll just move forward in time. Here she is moving around. This is, some of these are fires, some of these are harvesting, where they've cut the trees down, and she's moving all around. So that's what it looks like in Canada. And now what I want to do is give you a chance to look at it in somewhere else here in Kenya. So I will stop sharing now, and then we'll come back and I'll restart here on this practical demonstration. So what I want you to do is bring up Earth Engine on your computer if you can. All right, so if you have the ability to bring it up on your computer, that would be great. And I'll show you what I want to do then is to come here. I'm presenting the screen again, just going all the way back to the main link. And so, Nicholas, if you could paste this in again for everybody where it says these slides, to grab this part for people to click on so they could come back to this page if they want to. All right. And so I'm going to now click on the practical demonstration. Now that brings up a new tab. So I move to the new tab. And let's see, what I want to do, this is a big goal. I'm not sure if this will work, but we have about 30 minutes to go, and I want you to have a chance to use this BULC-D program and try it out. I'm going to need to explain it a little bit as we go, and we'll see if that works. What I would like you to be able to do is to come here and make a little poster. So I've made all of these blank posters, sort of a poster, for you to create. Now I know everybody's in a lot of different places. Maybe you can't really run Earth Engine and listen and click and all that. Maybe you don't do that. But if you want, you can do it. So let me encourage you, Nicholas, maybe you could come to this page, which is 3.Nairobi, your results with BULC-D in Earth Engine, and paste that into the chat so that people could come to that page and see where it is that we're going to work from. All right, so if you could do that. And that's one thing I don't know how to manage very well in here, is to be able to view what the chat looks like. But if you can do that, that would be great. And that will allow people to come to this same web page that I'm on. I'm now going to move to here where it says important information. All right. So let me ask you, if you can get to this page, if you're a person who could get to this page, can you maybe do a thumbs up with the reaction? I can see, you know, one link, maybe two links here coming. So maybe if you can do it, can you do thumbs up? If you cannot do it, maybe you could do thumbs down for a reaction, just to have that reaction come past, just to give me a sense of whether to make it open or sort of just show you how these parts work. All right, that's great. So I see I've made this completely open site, or an open document. And so you could see here, by accident probably, somebody created 2 new slides. That's fine, doesn't matter. We'll delete them later. What I want you to do is give you the ability to create a document that looks like this. So here, I'll show the slideshow. Here it's in Spanish, doesn't really matter. But these 3 guys did a land cover classification project. And over here they wrote on the side, here's what worked, here's how they did it, and here's what they found out. All right, so if I go up a little bit, the idea is go to any one of those pages and write down what you have done on the slide. Here's another group. This was for a presentation in Fiji. And so they said, we made it with 2017 to 2019 Landsat imagery. Their goal was to use it for coastal analysis. That's their goal. And so now these are available for you. My goal is to teach you how to use bulk, and then you come here and you add on here in the poster. If you can do that, it would be pretty neat. So what it suggests to do is for you to go to one of these pages, any one of these pages, and write your name up here in the corner. And that'll be like, you sort of grab that poster to type on. All right, there are 20 of them, you know, so there's a lot of them. And while we do that, I'll maybe delete these accident slides. That should be okay. And now what we are going to do is I'll show you the document. Now, if you can get to this slide, you can click on the script for this session. All right, now if I go and click on the script for this section, thanks, Emmanuel, that's great. That brings up not the book, but this other stuff here. I'll close the book. And that brings up this other repository. So this is a repository in my lab. And this is the program that I wrote with other people. So other students in my lab wrote it. It's version 50C. I forgot to share the tab again. All right, here we are. Here's the program that I wrote, and it's version 50C. Says it's BULC-D. It does all of these pretty more advanced things, but this is actually work that students of mine did, was to take my program and then turn it into a user interface. Now, if I click Run here on the BULC-D interface, you should be able, takes a minute to load all of the pieces, and then what it does is it will bring up an interface with 3 panels. The left panel will be the input, the middle panel will be the code, and the right panel will be the output. And I think I maybe didn't click on it while I was moving around. So I'm going to click on it again. We'll see if it will work there. That's much better. All right, so thanks, Christopher, for pasting that in. That's great. And so you can see here the way we've set it up. So I've put in coordinates for surrounding Kenya. You can do the optical sensor selection. And I'm going to click here. You see you can select Landsat 8 and Landsat 9 and Sentinel-2. And the expectation year, the one that was very level that we saw, 2021, running all the way through 1 to 365, going all the way down, 2022. Basically, I'm going to hit run at the bottom. So then I go on through. Here you see we have the ability in the future to use SAR, so synthetic aperture radar. For me, I'll leave off the NICFI images. Just leave everything as default is what I'll do. Constant, unimodal, then I'm going to hit Run BULC-D. It will zoom in to the center of the polygon that I made for Kenya. All right. And what it will show is down here, it takes a long time because it's running for thousands of images, but it can run over all of Kenya in one run, which is pretty rare for algorithms in Earth Engine. So I'll click hide, which will make this side go away. Here you can see if I say show, it comes back, but I'll just kind of move it over. All right, so this is somewhere in Kenya. I don't know where it is. Let's move back and find where it is. All right, so you can probably tell where we're at. And here's Nairobi down here. The center was up there. Now, if I go, I'm going to go back to the slides just for a moment. And I'm going to click on our script for this session. A bunch of you have done that. I see there's 5 or 6 cursors in there. And now I'm going to go to the training script. I'm moving quickly through the script, but what I'm saying in this typed document is I'm saying, yeah, all this stuff. So you do all these things. Here it is, 2021, those pieces. Okay, and where I want to go is I want to go to this location, which is Kikuyu. Let's see if we can get there. To do that, I'll go back here, share that tab. And now you can see some information has come in. You can see some of it is red, some of it is green, most of it is green, some of it is blue. All right. What I'll do first, I'm going to go over here to charts and click on charts. And I'm going to try to get over one of these red pixels. We'll move in here in a minute. So if I move in, it takes a few minutes to draw again. All right, so if I move in, it makes that chart. So this chart says the value in the place that I clicked on used to be around 0 for 2021. It was the same way in 2022, and then suddenly that number went down and stayed down. So that's like what I showed before, right, with those pieces. Now, I was zoomed out pretty far. So, all right. And so I'm not sure which exact pixel I clicked on. So we can move in a little more and see what it is that we are clicking on. Now we're going to go to Kikuyu in a second, but I'm very curious about this location. I'll click on one of these red spots here. And we'll see if it pops up, what it looks like. There on the chart. So there's another pixel where it used to be around 0.25. So that's like shrubs, a little bit of brush, and then it all went away from the looks of it. Now, maybe it was a dry year in 2022. Maybe something happened in this area. Maybe you know about it and I don't. It's real possible. So if I go to Kikuyu in Kenya, so what I do is I typed in those words. It then brings up a bunch of different locations that match that. All right. So I'm going to click on the first one. And I'm going to move over a little bit and move in to this area. All right. So the bigger idea of where we are, we're west of Nairobi here. Maybe everybody knows this location, but for me, of course, it's pretty new. So I wanted, if I want to get right to a place, I zoom in very far, then I type there, and that brings me like to that location pretty well. I got myself a little bit lost. Shoot, where did I want to go? I'll let this draw in the rest of the way. See if I can recognize where we were. All right, and so that allows us to go and we can look at places and learn about them, not only places that are forested. We'll do some edits and then share. Yeah, so you can, so you can do that. So let me just jump back to this. Sorry, I'll share the tab of what I'm looking at. So I'm looking here. You can go ahead. Anybody can do it. Yeah, okay, perfect. So I see Christopher's name here. I see some, it's hard for me to see it, but I think it says Anthony there. Sorry, Anthony, I can't see it very well. So anybody can type in there. And the idea, my hope is, you just kind of click around and find some neat, interesting image. So you remember before we were on the mountain. Now in the same run, we're in a different place. Let me move the probabilities back and see what that looks like it used to be. In 2021, I don't think it looked like that. I think in 2021, there were trees here. That would be my guess. Trees or vegetation here. That's what 0.5 of NBR looks like. Then sometime in 2022, in April, I think somebody changed this land and built what we cleared it, and now we have what we see here. Now we could use Google Earth Pro for that in order to look back at the images. Soon I'll make it that we can see the images over here on the right. That's some code that we're going to write this summer. But right now it's hard to do. But you can see here, this is like what I showed before, where the changing probability of that something is different than it was before. So here we begin and we think, nah, most places are the same. And then this is in this red area that I clicked. Then around April, as we started to get these low numbers, we became more and more confident that something had changed. All right, and so
we can't see a screen.
that's what you can see. So Christopher, I can't tell if you're talking to me or somebody else.
We can see a screen here. You
Yeah,
understand?
God, I forgot. I'm sorry. All right.
And and
I'll,
then the code on my side, the code is not displaying the app. I don't know whether it's on my side or yeah.
you say
So
the
maybe
code
someone
is,
else.
Yeah.
It's
say it
not run.
again.
It's not
Also mine
the
is
code
not
is.
running.
What? No,
It's
really?
not run.
It's running, but it's not showing results.
The app, yeah.
Why don't you share your screen? Let's take a look. Because that's pretty disappointing. Either Christopher or Michael. Christopher, why don't you share your screen?
Yeah, let me share. Oh,
Or
it's
Michael. Yeah, sure.
I think mine is okay now. I can see refresh. I think it's okay now.
Okay.
Okay. I think it was taking long to run because now it's okay. I can be able to navigate.
Okay, that's good.
Yeah.
So one thing,
Yeah,
there's,
it's okay.
yeah, okay. It took a long time for me too. I don't understand why. It depends on the load at Earth Engine. And then also there's a really strange aspect of Earth Engine where when you're running a very, very big run, uh, if you zoom all the way in while it does the run, it goes faster. If we zoom all the way out to all of Kenya, then it doesn't run. And the editor of the book, Nick Clinton, he said, I don't know why it works that way, but that's what it does. So for me, when it doesn't run, I zoom in all the way, and then it seems like it gets better. I don't understand the logic, but that's something inside on their servers. So, okay, so if you have the ability to see a little bit, or at least a few of you are able to see it, that's good. That's as good as I can hope, I think, for right now, for trying this demo. Here we were in Kikuyu. I wanted to go, I kind of lost the place that I wanted to go. Okay, there's Kikuyu. And I wanted to go to the west. That's what it is. Go to the west of Kikuyu over to this area. All right. And so when this run comes in, and of course you can export this run and then view it instantly, right? But to view a run over all of Kenya or over all of the world, which this program can do all at once, you can try that, but it takes a long time to draw into the interface. You see these little squares. For those of you who are maybe beginners, the little squares, each one of those squares is a computer. So they take the code that we have run and they send it to individual computers. And so each computer gets, I think, 256 pixels by 256 pixels, something like that. So when we look here, all right, oh, I suppose I turn that down. There, I'll turn it up. What this shows, what this suggests is that something changed around here, west of Kikuyu, in between 2021 and 2022. I'll click on one of those pixels for us to see the charts. And so here we can see a very clear expectation of land, of what we expect to see. I expect that every year is going to look like this. Now that might not be right because maybe the years 2022 was extremely dry, possibly. And I see that this is not a deep forest, right? It's a little green, but it's not like in the Congo. So, but the number dropped very low. It seems like a very, very low number for me. The idea of bulk is for it to be useful for you to look around and say, well, what's happening here? Here, I'll click on this green pixel. Why did the numbers change over here, but they did not change over here? Why does it look like there's change? And so here, if I click on a green pixel, that pixel says the numbers used to be like this. Now they're like this. They're about the same. There may be a little different. Maybe we were unsure in the middle of the year. But overall, what we see this year, in 2022, is just like what we saw in 2021. And my goal with this program is to provide you with the ability to look anywhere you want in order to learn what is happening and what is different. I'll zoom now for a moment over here. There's an area that's blue. What the blue represents, I'll see if I can click on it. I kind of missed where it was. Yeah, this little blue pixel here. I think there was a blob here that's blue. Blue means that the NBR number went up. So I clicked here. I'm waiting for it to, I'll try it one more time. Should come in okay, I think. So, the program is right at the edge of what Earth Engine is willing to do for memory. And so sometimes it says memory is too much and sometimes it doesn't. But if you get that little message, you can click on it. So here in this blue pixel, it said, well, I expected to see these numbers. Here's my fit. And the numbers I got in 2022 were really all higher. What does that mean? I don't know, but that's up. The idea is for you to study it or to be able to study it. So it says somewhere here in this area, we think that there was some, it's more green basically in 2022 compared to 2021. So I'll do one more thing and then turn you loose. So the instructions then say, all right, you don't have to only do 2021 against 2022. You can also do it for 2024, which is like right now. So I'm going to change the target day of the year to be 90, so the end of March. So what I'm now asking is 2021, I could do 2022 if we want, but 2021 or 23, I'll just leave it there, 2021, and then compare it to what we see now, this year. You see we can fit a curve that is 1 sine wave or 2 sine waves or 3 sine waves. If that's unimodal or bimodal or trimodal, I'll just leave it at 1 sine wave. Now I'll click on Run BULC-D. This creates another run, goes back to their servers, zooms in close again so that it runs with that strange trick that nobody understands. I let it come in a little bit. I wait a minute for it to start working. You see here it builds the expectation. It's fitting the sine wave. That's kind of the first stage. And then it compares the new data to the first stage. That's what it's doing. Over here, it's drawing the new value. Kindly share the code link. All right, so if somebody could paste that in, if you know where it is, if you could share that to them, that would be great. So now this blue and green and a little bit of red, perhaps this is a new road. It's possible. I don't know if that's likely, but it gives you a chance to explore. What I'll do now is come into this part of Lake the edge of Lake Victoria. All right, I'll come over here, and here I'll just share for a moment. I'm going to go back to the instructions tab. So this is this area west of Kikuyu where we were. Then you can also make a movie, and the movie shows the changing probability through time, or my estimate of the probability through time. Here last night, the movie option didn't quite seem to work, but I think it's okay. And what it shows us, you can do some analysis where you can say, show me the places where the value used to be 0.5, but now it's 0.2. And you can highlight them to be different colors. You could do that by coming into the analysis button. You see the movie, analysis, chart inspector. I guess we've changed the order since I made this picture. But the chart inspector's first, then the movie, then the analysis, and then some other thing. And so you can set this and do it, and then you see this image that I made early this morning in that area west of Kikuyu. Now, if we want to get to this place of Lake Victoria, you can do a search like this. I'm going to grab these coordinates, and now I'll go back to Earth Engine, reshare the tab. I then, instead of searching there, I paste that in here. That's another thing that you can do with Earth Engine. You can zoom to a particular location, and you zoom to that place. Now, I can't tell where it was, so I'm going to zoom in very, very close, just using this little trick. Then I hit the button, and so this is, now I'll zoom out a little bit. This is the area that I want to show you. So here again on the shore of, part of the shore of Lake Victoria, here is some indication of some changed land. Of course, I'm not from anywhere near here, so I don't know if it's real or not. But the idea of BULC-D is to give you the ability to inspect those areas. So if you're doing a study around Lake Victoria, you might say, well, where am I supposed to go? Should I go here, 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 here? But the idea is for BULC-D to help you to know more evidence about where to go. So here's this area. This is an old image. This is the background image of Earth Engine. And it shows that maybe this was a field in the past. It had regrown somewhat. And now the evidence says that it changed, that something changed. So I'll move this over a little bit to get back to charts. And let's see what these charts look like. If I click here, I want to know what that looked like. Now you remember it was 2021 compared to 2024. So here it's making the chart, and oh, perfect. This is the pixel I wanted to go to. So here you see a unimodal, like one sine wave is maybe not really a good idea for this. It's maybe not a very good fit. Over here we have, it tells us we have the ability to look at the R squared. So how well did the blue curve fit onto these red points? I don't think it's very good, but I just left it to illustrate this. If we look at just January to the end of March, now this image is from March 22nd. That's from yesterday. And so we can see the numbers are much lower than we would have expected. They're negative 0.11. Negative 0.11, all 2021, we never saw any numbers that were negative. Here's a bunch of numbers that are really very low. So there, I think, is a good chance that if we inspected these images in this place, that this area changed, comparing 2021 with 2024 in this exact place. And so that's what I'll encourage you to do. That's the things that we can do with bulk, okay, with BULC-D. I mentioned this movie. I'll just do it while I'm talking. Set the frame rate to make just a little illustration movie. What that does is it takes this border and it makes a new, it's called a thumbnail, and it makes a new movie. And that movie should show us places that we believe changed and places that we don't think they changed. So you can see at the beginning, everything is green. And then it says, well, maybe you see it turn into red as it gets some more evidence that places changed. Now I made this go very fast. It's maybe too fast for us to really process. And of course, if I want to move in and see just this area, maybe not so fast, I'll just say 1 frame per second. Now the program will recreate the thumbnail. And I'm really proud of this. This is work, again, that, that an undergraduate student in at my university did. She did this for the summer last 2 years ago, maybe. And she created this. And so here it says, okay, I think that this has changed. That's what the white represents. The white layer is the probability that the value went down. And so here we can see the understanding for every pixel, the logic growing. So this is to go back to the dice. The estimate that it changed, or the estimate that it's unusual, that's what we're trying to graph here. And so then it moves on a cycle. This thumbnail, you can do save image as, and then it makes a little GIF. And so to go back then to finish, for me to finish, I'm going to leave you to use this and be finished with the presentation for today, because it's Nicholas asked me to go to 10:30. To go all the way back then, I'll change back to this tab. Okay. So you saw the Earth Engine book, Fundamentals and Applications. I'm going to just go to the book itself. I'll change here in just a moment. I'm going to go here, sharing this tab. You saw that little movie that we made. Well, I didn't know how to make a movie, but I saw it in the book. When somebody was writing this book, I saw they made a little movie. And here, I'll share that tab. I saw they made a little movie here. I think it was in the urban environments chapter. Yeah. Here in the urban environments chapter, as she was creating her paper. Oh, I think this is the one. There's some movie in here. The thumbnail. Oh, I don't know where it went. Oh, maybe it isn't in the book. Hang on for a second. Oh, that's bothering me. Sorry. THUMB. There it is. So we didn't put the thumbnail into the book because we wanted the book to be able to print, and you can't print a movie on paper. But the code here in code checkpoint A12A, I'll now move to that. So my goal here is to show you how these pieces can work together. So I'm going to go, I'll make a new tab. I'm going to share that tab. I'll go to code.earthengine. The tab, the thumbnail was A12A. So we go here. I'm going to go down. I'll go to the Earth Engine book. Then in there, A112A. And so here I hit run. See over here, it says generating thumbnail. So for me, as a pretty expert user, this is how I learned how to make the thumbnail. And this is the chapter that I had my student learn. I said, okay, go learn this, learn how to make the thumbnail. I can't figure it out. So she went and did the chapter, learned how to create the thumbnail, and then she brought that knowledge back for our program for BULC-D in order to make this, to make the animation. And so here's the animation. It's the same idea. It uses UI.thumbnail. We have it buried in our code here. It's down in here somewhere, the interface widgets. You know, this is this program that she wrote for her year. So to come then all the way back and finally stop talking and let you go back and have the rest of your day. We learned about the Earth Engine book. Here's another UI thumbnail that is from some different research that I didn't present today. I tried to explain BULC-D, this Earth Engine program for change detection. Hopefully it's useful for you. My real hope is that at least a few of you will decide to stay on the, stay on the call and paste in a few things here. Pick some kind of image and put it in there. For me, I want to know if BULC-D is useful for people. I've really only used it for tropical humid forests. That's what it was developed for. So I believe, though, that it's useful in other places, but I don't have a lot of evidence for that. So if you have good success, I'd like to know. If it doesn't work for you, I'd like to know. If there are other pieces that are useful for you, I'd like to know. You know, the R squared that I showed you about the fit, that came from a request from a person who's using BULC-D. He said, I want to know whether the blue line is a good fit for the points. Can you calculate the R squared? So we worked together and figured out how to calculate the R squared. So then, to finally finish, we'll come back here. So we've done the Earth Engine book. We have looked at this program of mine for change detection, and I've given you the ability for a practical demonstration. That's it. I want to thank Nicholas and thank the rest of you for being here and being on the call. It was a lot of fun for me, and I hope that it is enjoyable for you. All right. Thanks very much, and please feel free to keep in touch.
Okay, so thank you very much, Prof. This session is really insightful for us, and for sure the content we have to appreciate is really great. So, but before we go too far, I wanted to welcome any questions because I do believe some of us here have some questions. So, please, you can open up your mic, give a short brief of yourself, then you can ask a question or do a comment to Prof. So, any question, please?
Yeah. Okay, maybe I can start. Right, Nick?
Okay.
Okay, thank you so much. Thank you, Prof, for this really insightful presentation. Actually, I've really learned a lot in this presentation. I'm Michael Wafula. I'm also part of the organizing team of Google Earth Engine Nairobi. And mine is just first of all to start by commenting about the presentation. Sincerely speaking, I think there's much that we need to learn about Google Earth Engine. For now, I rank myself maybe intermediate there or advanced, but there's much that I can still learn based on what you've just presented, and also based on the book that we've just launched. For the book, I have used it sometimes back. I think when it was not officially launched, because I think it was out before even it was launched. Yes, it is really nice, and I don't know if there's any update because I was using the other version. So if there's any, I can try to check it. And then also based on what you've presented, I had a question. From this code you've shared, I think we have been actually looking into a way of generating a report after you've done Google Earth Engine application, like the one we've just shown here. I don't know if it's possible to generate a report which can eventually be downloaded as PDF or something, if it's possible for that.
So what would a report look like? What kinds of things do you want in the report?
Okay, yeah, thank you. So basically, we are looking at a way of trying to assess water quality parameters. Of course, basically different water quality parameters, that is, which will eventually transform into an application. And lastly, we'll be able to assess different water maybe bodies, and then be able to extract the quality, if it is water turbidity, total suspended solids, and so forth. Yeah.
Okay. Let's see. So I'm not sure that I'm going to answer your question very well, but let's see. So for making reports, I mean, honestly, what I do is I do a capture of the screen and then I paste it into a document. That's the best thing to do. For my specific program, let's see if I go back here. Sorry, I'll just share it one more time. One of the things that we have my program do is we have the ability to create all of these layers. So, you know, to write them out. So here's the final bulk probabilities. That's the red and green and blue. The probability that the value decreases, that's the white one shown down here in the corner. And can you, did I share the screen correctly? Are you able to see what I'm talking about?
Yes.
Okay, sorry.
Yes.
I just did it wrong so many times. All right. So, so you can export the layers. And once they're exported, let's see, if I click here, then there'll be a GeoTIFF. You can send them out to the drive or cloud storage or as an EE asset. For me, I do it as a drive and then I get a GeoTIFF. Then I can read the GeoTIFF into QGIS, and then I use that to make the report. And so for constructing a report, that's what I do with the outputs. The other question of well, I don't know. Does that help with your question? Your other question was about water quality specifically, right?
Yes. I think it was tied to making a report, and I think you've answered it. Thank you.
Okay, great.
Yes, thank you so much.
You know, maybe one other thing to say about the water quality indexes is in the middle of the talk, I said we have a lot of lakes in Canada. And the Lakes of Canada is, or the lakes everywhere, is a project that I'm also interested in working on. We use different indexes for that. So the NBR, the NDVI, those are not the right indices for water quality. So for something like Secchi disk depth, we have the ability to make those indexes and then use bulk also for asking whether those indexes have changed over time in lakes. I haven't done that work yet, but we've got you know, the ability to do that. You could look around at all different lakes in Canada and see whether whether the other index has changed.
Okay. Yeah, thank you.
So,
thank you.
possibly. All right.
Okay, so I know there are some questions, but also I also want to know, like, for the reports that we have been able to generate with the bulk, is it possible that we can extract the data that is generating the charts and do some further analysis, probably comparing it with the in situ data which is available in the labs, such kind?
Okay. So for, I think, not yet. So let's see. So if your question is, can we, like, can I click on a point and get the data out for the that it's using for that, right? Is that the idea? So
Yes.
I think I haven't done that in bulk, but I think that there are other existing pieces of code that other people have written to do that. So maybe that would be a good idea, a good thing to add. It's pretty possible to say the last thing I clicked on, then we would put it into a little piece of memory, and that could be something to export. So I think that's pretty neat. That's possible. Actually, I think we might do that. That's a good, nice idea.
Okay, thank you. So I see Joseph here is also raising his hand, probably. Yes,
Okay, sure.
Okay, thank you so much, Jay, for the nice presentation and for the nice book which you incorporated with your team and you achieved the goal by printing it. And it's so good for the community, just like pollination of the knowledge to the world and the humanity for social good. We appreciate that. And so my question is, possibly I've seen the BULC-D basically using the Landsat 8. I haven't seen it using basically the Landsat 4, or I think my code had a problem over there. I don't know why.
I think I couldn't hear you very well. Could you say it one more time? I hear Landsat 8. I heard you say the nice thing about the book. Thanks. Thank you very
Okay.
much. That's great. The thing about the Landsat 8, I didn't hear it.
Yeah, for the Landsat, for the BULC-D, I've seen it using basically Landsat 8 for the analysis. I haven't seen Landsat 4.
Ah, okay. So it uses, well, we have the ability to use all different sensors. So it can use Landsat 8 and Landsat 9 and Sentinel-2. That's usually the package that I use when I do it. So over here, if I'm hearing you right, I'm not sure I heard you all the way, but over here, I can say I want Landsat 8 and Landsat 9 and Sentinel-2. Is that helpful? I don't know if I answered very well here.
Yeah, that's helpful. And also another question probably, basically, is it using is it dependent on the temporal resolution of the images?
It does depend on the temporal resolution of the images, yes. And that's really complicated, right? Because if we have just Landsat 8, that comes every 16 days. So we only have an answer that updates every 16 days. But if we use 8 and 9 and Sentinel-2, if it's not very cloudy, we can change the step size to be down very small. I'll move it down to be like 1 day and then run it over here. I'm not completely sure it will work because the step size very small means that it needs hundreds of iterations. But if the data is frequent, it makes the calculation more complicated because it runs for every day that we give it the data. And so in an area where there's not so many clouds, the data resolution is really good if we have Landsat 8 and 9 and Sentinel-2. But we just did a study in Gabon, and it was really difficult because it's so cloudy that there's only 1 image per year, 2 images per year in a lot of those places. Here, if I click on a chart this is for 2024, you notice I moved it down to say 1 day. We'll be able to see how much more data there is in Kenya compared to Gabon. It's so much more because it's not cloudy, not as cloudy. So the program is related to how much data there is, right? So here there's already 3, 6, 15 or 20 images in 60 days, 65 days, however many, 80 days. And so we have there are a lot of images over Gabon that are just clouds, right? It's the same number of pictures, but the number of usable pictures is a lot bigger here. So bulk, I expected to do much better here where we're looking today compared to in Gabon. That's part of why we added the SAR. We're adding in the SAR work. So there's Sentinel-1. There will also be a program or a new platform called NISAR, which will also help us to identify changes. But SAR data is so noisy that I'm not sure if it's going to work. Okay, that's too long of an answer. Any other questions today?
Thank you for that.
Okay, thanks.
Okay, so thank you very much, Prof. And this was really an exciting session because getting to understand the power of BULC is really important because for us we had an opportunity to interact with the writer of Splash Authors and where we attended a training session with him here with Michael, Chris, also, and yeah, some other fellows. So it was really an exciting session with him and also the WRI team where they introduced to us the NTW data, the dynamic world, which now we can see that the bulk is able to integrate the W data and make it more useful because we worked on a project in Lake Nakuru and what we were doing is that we were trying to improve the accuracy of the W with the essential data. And you see now if we add the bulk it could be something very easy for us to work along. So we are realizing the very power of Google thinking and the tools that we can develop here is a community of Google thinking developers. So most of us here they are scientists, they are researchers, we have also the industry practitioners who are using the Google thinking in different capacities, and we do appreciate every way in which our members are using the Google thinking technology, and we devote ourselves to continually empowering the members and making sure that everybody can sustainably, at his or her own capacity, do a good project. And we do appreciate the presence of all our speakers here and Jeff, Prof, that is really commendable your size. Your project is a challenge to us because for us we are with training and this year we were focusing on working on some projects, and we we are highly motivated to have you present the work project that is really important. So we are grateful, and should there be anybody with something to say, we can you can just raise up or you type on the chat because in the next 1 or 2 minutes we are going to end up the meeting. The video will be shared via our channels, and also you can get to subscribe into our Google group so that all the events you can get notified through that channel. Unfortunately, we do not have any WhatsApp group, but we highly use the Google group where we can push our conversation because that is big enough to accommodate all of us. So we highly recommend you that you can subscribe to that Google group. Also follow us in all our other social media channels like LinkedIn. We have also Twitter and YouTube. Like all the sessions recorded are available in our YouTube channels, which I see Christopher has shared a link. We also had a LinkedIn link shared through the chat, and also the Twitter. You can follow us along that line. That will be really grateful. Thank you so much, everyone, for sparing your time to be with us here. And Pro, we really appreciate our conversation started last year to have you here, and this is really great that we have made it happen today. So thank you so much, Pro.
Okay. Thanks a lot, everyone. I really
Thank you so much,
appreciate you being here.
Uh, I see Irene here as yeah, I see one of us here, Irene, as a question. Also, Frederick also raising his hand. probably we can give them some time to ask. Yes, Irene, please.
Nick, thank you. Prof, sorry for taking you back. I think I lost my mic on the way, but now I had a very brief question. My question is, I saw from your presentation you're doing a lot of change detection. Just wondering if this book has other or depicts other case studies for other applications.
It does, yes. For change detection is my own research, but the applications chapters have all kinds of things in them. So there's the one I'm thinking of. There's the one for mangroves. There's change detection in mangroves. There's some other change detection ones for forests. Those are the biggest ones. I think for maybe the urban one also has changes in time in urban areas. So we tried to make a balance between seeing things and seeing changes so that it wasn't only viewing or only looking for changes, but some of a blend of each of those. So yeah, I think if you look through the applications part, I think you'll find some good things, I hope.
Yeah, of course, I'll have to take a look at it. I'm not a pro in this, but it's on my line of work, and I'm currently working on a project for estimating carbon sequestration.
Okay.
Above women. So I was thinking, that's why I'm asking that question, to see if how much help I can get there. And also my last question is, do you allow people to reach out to you in case I have a question on the book or something that I feel like you can help?
Yeah, definitely. You can contact me anytime. I will say I'm not very good at writing back to people.
Okay.
I'm not very good. Not because of I'm very disorganized. So if I don't write to you right away, then you just write a second time. It's fine. So, and in fact, with Nicholas, he wrote to me once, and then how long? It took like 6 months. I wrote back to you or something. It was terrible, embarrassing. So Irene, if you write to me and you don't hear back right away, then you please write to me a second time. That's fine.
It's okay. I hope you'll provide your contacts, maybe your
Okay.
email or your platform, website, anything.
Yeah, for sure. Nicholas, maybe you could type my. Oh no, I can see. I just can see where that is. So I'll write my thing there. Jeffrey.cardille@mcgill.ca. There. So, and one other thing, Irene and everybody else, is I think it's really hard to have discipline and move through a book line by line by line. We get distracted. I get distracted by email or listening to music or other things.
Mm-hmm.
I believe that having the videos can be really powerful. I watch the video. I have to lock into the video mentally. So for me, I think it could be really helpful for a person to have the video of a person explaining the chapter, and they move through the chapter, and then they explain it over here, and then on this side, I try to do the work that they're talking about. For me, I think that's a good way to have the mental discipline to move through. I think if I just have a book, it's hard for me to focus, but having someone talk and describe, that makes it a little easier for me. So we have that there for people.
All right, thank you. This was a very nice presentation.
All right, thanks very much.
Thank you.
Well, thanks for your time. I appreciate it.
All right, so thank you very much, Prof. I think we can now close the meeting if there's no other agenda. So,
all right. Thanks, everyone. Good luck with